Welcome back, audio coding traveler. You came here to learn more about how I made my plugin Hammer und Meißel. Or you came here for today's topic specifically. Look at the interface of my work-in-progress plugin build. It contains multiple visual components that inform you about the space their shapes live in. I'm talking about the rulers in the Modal material editor in the center and in the two envelope generator editors on the left. My name is Florian Rugala, this channel is called Beats Basteln, and in order to bastel beats, you sometimes wanna know how long your envelopes are. That's why in this video we take a deep dive into the code of my ruler class and find out how it is implemented, customized, and how I wrote it. But first let me show you what you can do with it. In response to modulating any of the time parameters of the envelope generator, so attack, decay or release, the ruler adapts to the length of the envelope. Note that you cannot see the length simply by looking at the envelope's shape, because it is always shown relative to the width of the component it is in. I called this concept relative time envelope in a video I made about a year ago, in which I explained the envelope generator of my plugin ADSR in an early state and also expressed my opinion about them. I'm a big fan of relative time envelopes because then you can use really short parameter values and still have good control on the actual interface of the envelope and not just on the knobs. Still, I did not figure out how much of an impact a ruler would have on such an envelope back then. Anyway, this is EnvGenView, the component that represents the shape of the envelope. It has an object of the ruler component. In EnvGenView's constructor I call initRuler, which adds the ruler and makes it visible, as well as giving it a few customizable properties, such as the way it increments values, defining the way values are interpreted as text, the color ID, and whether or not the first value should be shown. At the moment, the ruler is incrementing in 100 millisecond steps, from 0 to 100, from 100 to 200, and so on. But once the length of the envelope exceeds 500, the increments start to go in 200 millisecond steps, and by doing so, tidying up the space between the increment strings. Once we exceed 1 second, you can see how the values are now written in seconds instead of milliseconds, because typically less precision is needed on higher ADR values. No matter how wildly I modulate the parameters, the first increment is always just 0 milliseconds, which doesn't add any non-obvious information. So I made it possible to only show every other value, but that is also not 100% satisfying, because then the ruler doesn't seem to align with the symmetry of the EnvGenView anymore, because the anchor point of the ruler is invisible now. Let's have a bit of an intermezzo about number sequences, shall we? Here you can see some footage of an earlier state of this code, where I still hard-coded the increment values for different ruler lengths. That might look a little stupid, but it was a really good way to try different things before settling for this number sequence that always traverses between 1, 2 and 5 before going into the next highest range of values like 10, 20, 50 and then 100, 200, 500. Needless to say, I wasn't happy with all the magic numbers here, so I hoped some AI could help me figuring out how to calculate the increments with a neat little function instead. I asked GitHub Copilot Chat. Similar to ChatGPT, it wants you to explain the problem and then it tries to have a conversation with you about it. It misinterpreted my request here though. Yes, it made a function for calculating the increment value, but then instead of giving me the math that generates the value, it allocates a lookup table from my hard-coded values instead. That's worse than what I had and overcomplicates the code for no reason. The only thing cool about it is that the vector is static, because that means that it doesn't have to reallocate on every new function call. That's kinda smart. I asked Copilot Chat again and said that I don't want it to be a bunch of nested ifs, and it gave me this code which just uses normal ifs, but essentially suffered from the same problem. I mean, it's kinda cool that AI can find multiple alternative ways to write the same thing, but if it's not improving the situation, it's not good enough. I also asked ChatGPT about it, and it gave me pretty much the same answer as Copilot Chat, with the only difference being that the end of the code being even more obscure and unreadable. Makes me wonder what kind of fancy pants developers ChatGPT has done the code for this prediction. This situation shows that either I have trouble explaining myself to AI efficiently, or AI is not very good at interpreting given patterns in its input matches. Or else, it could have noticed that the magic numbers were representing a number sequence that follows a clear logical structure. Apparently, this number sequence is called expansion of GF. This is the online encyclopedia of integer sequences, a website where you can type in a number sequence and it tells you everything it knows about it. Unfortunately, the given mathematical terms can look rather cryptic, and there are not always C++ examples, so I wrote my own function. And this is it. This is what Copilot Chat and ChatGPT couldn't figure out. Just a function that says, okay, here are the values 1 to 5. They relate to the values 0.2, 0.5 and 1. And whenever the length of the ruler is not below one of those values, multiply them all with 10 and try again. Easy. That was way too easy for having wasted so much time with AI to solve the problem. I often love how Copilot speeds up my workflow, but it's important to never forget that our own brains are stronger than every supercomputer on Earth. We just need to use them. Skip forward if you came here to just learn about how the ruler class works. Obviously, the moment I release this video, the plugin has already been released. But I still want to ask you, how should the increment values of the modal material editor work? Here you can see a simple saw wave modal material, where every partial is on a perfect integer. Highlighting the integers like this makes sense, because partials on perfect integers are part of the harmonic series. The harmonic series is dominating most instruments' timbres. But here on the square wave example, the increments skip every other partial to avoid overloading the modal material editor with too much information. However, it could mislead people into thinking a partial is not part of the harmonic series if it's not on grid with a ruler. Also, there can be modal materials like this, where it's not much about the harmonic series anymore. Would you use increments of 0.5 or 0.25 so that it's a power of 2 of x thing? Or would you go in 0.1, 0.2 and 0.5 steps like I did with the envelopes, or some completely different type of number sequence or logic? Now that you know how my ruler is being implemented and customized, let me show you how it actually works internally. This is the ruler struct. You've already seen its makeInc expansion of GF function. And if this function can't expand your GF sufficiently, you can also set any other function for setting increments. In the paint method, it only draws anything if the ruler has a length. For example, if an envelope neither uses attack, decay nor release, the envelope shape implies no length, but just a fixed value at sustain. If there is length, I paint little vertical lines next to all labels. Resized updates the ruler, just like setLength, because both functions are processes that can rearrange some label properties. The labels array is a vector of unique labels. So as you can see, you need a dynamic amount of labels depending on the situation, which is why they have to be wrapped in unique pointers just like all other juice components. The update function starts by removing the labels from the ruler and clearing the vector, and the function ends with all labels from the vector being added to the ruler again. If there is no length, there is no need for any calculations, so you can immediately return. But in any other case, you need to prepare an array of labels. You already know which increment value you want for a certain ruler length, so you can calculate the maximally needed number of labels as the ratio between the length and increment value. Then you iterate over it and add labels to the dynamic array with a given text, font, justification and color. At the time of making this video, I still had this magic number 100 here as the width for each label. It would be better if it had the exact width that is between each step, but yeah, I haven't figured that out yet. Maybe I will when I have released the plugin. You can check the code to see if I did. But the most important aspect is that the X value places the label right next to the vertical line in Paint. I also added this little paint stripes function, which is actually not used by the paint method of the ruler directly, but it can be used by the paint methods of the classes that use the ruler instance to draw a grid under the ruler, just like I did with the Modal material editor. You can see that it's pretty straightforward to set that up, with nice little input parameters for the top and bottom of the stripes, and an argument for the density of the stripes per line. That's it, you reached the end of the video. You have now gained the power to write and use a ruler in your plugin projects. Use it wisely. All those lines and texts can easily clutter in interface, but without a ruler, you don't easily see what certain surfaces are even displaying. I can already see myself making an updated video of this in some future, when I need zoomable rulers that don't have their anchor point at 0 anymore, or when I wanna make vertical rulers. But for now, I just call it a day with this nice little tool for you.